This is the video to help you complete the voltage and current laboratory. Take your travel flashlight and just make sure that it works. Now remove the bottom of it. So unscrew the bottom and remove the battery module. Take the batteries out of the module. Like so. Inspect the battery markings. We see this battery is a AAA, and that indicates its size and shape. We have here the nominal voltage. This tells us that the nominal voltage is 1.5 volts. Also, the battery has polarity markings. We can see that this end of the battery is the positive, meaning that the other end is the negative polarity. This tells us that the voltage of this end is higher compared to the voltage of the other end. That would mean that a charge that travels through the battery, a positive charge traveling through the battery this way, would acquire energy. Our next step is to set up our multimeter to measure DC volts. This step can be different depending upon the type of multimeter that you have. This meter is a manual ranging type meter. One has to select what is called the full scale deflection. In our case, we are going to use a full scale deflection of 20 DC volts. So turn the dial of your multimeter until the marker on the dial aligns with the 20 DC volts setting. That's if you have this kind of meter. If you have an auto ranging meter, then you will find that the DC volts setting is indicated by a solid line, and underneath that a dotted line. So if I wanted to turn this to DC volts, I would turn this indicator on the dial to this setting. The multimeter comes with a set of leads. The leads are colored. One is colored black and one is colored red. The different coloring allows us to keep track of which of the polarity with which these are connected to the meter. Each lead has two ends. This end here is the connector and is used to connect the lead to the multimeter. This end is the probe, and you see it has a sharp tip, allowing us to precisely place this tip onto our circuit board or circuit so that we can measure the voltages there or determine the current through a particular path. To connect the leads to the multimeter, we will connect the black lead to the common, the COM. Make sure it is firmly connected. And we will connect our red lead to the marking with the socket here associated with the volts. So this socket has multi-purposes. It can measure volts, ohms and milliamps. So to measure volts we need to connect to this socket here. This other socket you see is indicated for measuring 10 amps DC. So we need to connect to this middle socket, which is labeled volts. We now have our multimeter connected correctly to the leads so that we can probe voltages on our circuit. If your meter has an on-off switch, please turn it on. Otherwise that may not be necessary, as some meters they automatically turn on once you move the dial away from the off position. When you turn the meter on, there will be an initial reading shown here, which is measuring the voltage across the probes. Sometimes if the probes are not connected to anything, this reading may fluctuate because of noise being picked up by the meter. Our next step is to measure the battery cell voltage. We notice that there are two conducting terminals on each battery, the positive and the negative. The positive tends to have a raised central area. Have a look at your battery and identify the conducting area associated with each terminal. You can place your battery down on the surface, and to measure the voltage, take your red lead and put it in electrical contact with a positive, and take your black lead and put it in electrical contact with the negative terminal of the battery. Apply a little bit of clamping force so you have a good contact. The reading should stabilize. And I see for my battery the reading is 1.52 volts. This is above the nominal voltage of 1.5 volts, so my battery is in good condition. In the next step, we will investigate what happens if we reverse the connections. So if I put the red lead on the negative terminal and the black lead on the positive. The meter is measuring the voltage difference between the red lead and the black lead. We see that we get a negative reading. This is telling us that the red lead is at a lower voltage than the black lead. For the next step, leave your meter in the same configuration as before. Take one of your cells and tape it down to your surface so it is held stable. Avoid getting tape on the terminals, otherwise that may prevent electrical contact. We are now going to try different configurations. The first configuration is two cells in series. They are called in series because as a current flows through here, all of the current passing through here must then pass through this other battery because there is no other path for the current to go. These two batteries are hence in series. Take your black lead and put it in contact with the negative terminal of the first battery, and then take the other lead and put it in contact with the positive terminal of the second battery. Just squeeze them together slightly so that electrical contact is maintained between all the elements here, and note the reading. The next thing is to reverse this battery and measure the voltage. Again, black lead on the negative of the first battery, and the red lead is going to be at the top of the stack, which in this case is with the negative of the second battery. And I'm getting 0 volts. So don't be surprised if you get 0 for that. There's nothing wrong with your instrument. although you may want to check that everything is in good electrical contact. For the next step, we're going to put 3 batteries in series, plus, minus, then the plus of this battery and this end being negative. Take your black lead and put it on the negative of this, what is now the first battery here. Put the positive on the other end. It may be easier to apply your force along the axis of the stack to keep the batteries clamped together. And here we go. This is my reading for 3 batteries in series. It's quite difficult to keep the batteries in contact. There we go. So I'm getting a stable reading now. Note that reading. Then we will reverse one of the batteries. Note the reading. For the next step, we're going to put 3 batteries in series, plus, minus, then the plus of this battery and this end being negative. Take your black lead and put it on the negative of this, what is now the first battery here. Put the positive on the other end. It may be easier to apply your force along the axis of the stack to keep the batteries clamped together. And here we go. This is my reading for 3 batteries in series. It's quite difficult to keep the batteries in contact. There we go. So I'm getting a stable reading now. Note that reading. Then we will reverse one of the batteries. Note the reading. Now we will reverse 2 batteries, like so, and measure the voltage. And we're done with that part. At this point, reassemble your flashlight. Make sure you put the batteries back with the correct polarity. The negative should be against the spring contacts and the positive against the flat contacts. Make sure your flashlight works when you put it back together again. We will now prepare our multimeter for measuring current. For a meter like this, we want to connect our black lead to the common and our red lead to the 10 amps DC socket. So our black lead to common and our red lead to 10 amps DC. we want to turn our dial now so that the dial marker is going to be on the 10 amps setting. This will allow a current to flow through the meter so that it can be measured. On an auto-arranging meter, a similar process is used. Connect your black lead to the common and connect your red lead to the socket marked with an amp. You will then rotate your dial until it is on the 10 amp DC setting. So the DC is indicated by a solid line with a dotted line underneath it, and then the amp setting is indicated by an uppercase A. Take a translucent object, and we're going to take our flashlight and we're going to put it lens down onto the translucent object so we can tell when the flashlight is going to be turned on. Normally we turn the flashlight on using the switch. Let's remove the bottom, the switch end of the flashlight. And what the switch does is it provides an electrical contact, basically makes an electrical connection between this outer case here and this central conductor. By doing so, it allows a current to flow between this center portion of the battery module and the threaded part, the silver threaded part here of the case. To measure the current, instead of using the switch to make that connection, we will use the ammeter or our multimeter, and the current will then flow through the ammeter, and we will be able to measure the current being drawn by the flashlight when it is operating. So put your negative lead, your black lead, onto the center of the terminal of the battery connector, and the other lead on the shiny threaded part here, which is conducting of the barrel of the flashlight. You will see that the flashlight turns on and the reading on the meter tells you how many amps it is drawing. So it may fluctuate a little bit, so just give an average reading. So mine is about 0.5 of an amp. And that's all the measurements required for this lab.